All right, looking at the second part of this question, things stay mostly the same except for the fact that we are looking for the probability that at most 14 of these 20 households have access to high-speed internet. Now, at most 14 includes the numbers 14, 13, 12, 11, 10, 9, 8, all the way back to 0, because we always have to consider 0 because it's possible that none of these 20 households have access to high-speed internet. So let's go to a couple of slides forward here, and we're going to look at this problem. Alright, so as I said, in order to answer this question, if we did it the really long way, we would have to calculate the probability that x is equal to 14, calculate the probability it's equal to 13, 12, 11, etc., all the way back to x is equal to 0, calculate all of those individually, and then add the whole works up. Now that's way too much work for me. So instead, in questions like this, we tend to use something that's referred to as cumulative distribution function, cumulative probabilities. And cumulative probabilities are always written as less than or equal to. So I'm not going to show you how to work this one out by hand. I'm simply going to go to Minitab and we are going to get the answer. Alright, so back into Minitab here, and back to our Calc tab, probability distribution. We're dealing with the binomial. Now the parameters of our binomial haven't changed. We're still dealing with 20 households selected at random, 80% of which have access to high-speed internet. My constant this time is going to be 14, but you gotta pay attention here. We no longer want probability, we want cumulative probability. So if I leave my radio button here, it's simply going to give me the probability x is precisely equal to 14, but I want the probability x is equal to 14, 13, 12, 11, 10, blah, 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 all the way back to 0. I'll click OK, and here's my answer. So in terms of the difference between what I saw in part A and what I see here in part B, part A says probability distribution function, and the probability is done in terms of equal to. This one says cumulative distribution function, and the probability is less than or equal to. So when you're doing these problems yourself, you're going to have to be cognizant of the fact of whether you need to use equal to or less than or equal to. And of course, Minitab also tells you, and you should check to make sure that you've done this right, your sample size and your event probability. So here's our answer. Probability x is less than or equal to 14 is the 0.195.